Welcome to Open Dialogues. Open Dialogues is a live stream webinar series designed as a conversational companion to the AI infused newsletter. Each 30-minute session features a roundtable discussion with 1 to 4 guest speakers covering three rotational topics in a transparent ask me anything style format. So, all the topics that we're addressing in these webinars are things that we're writing about through the newsletter. So, if you want to check that out, you can go on get-ai-infused.com. But with that being said, my name is Joaquin Milada, and I'm a writer here at AI Infused. Benjamin, would you like to say a few words about who you are and what you do?
Yes, so I'm an AI researcher and an ontologist by training. I have 29 years experience in developing symbolic AI systems, and I am at present very interested in synergistic combinations of symbolic AI with probabilistic or generative AI, such as characterized by large language models, for example.
Thank you, Benjamin. And Benjamin is also a writer here at AI Infused. And Shutri, would you like to say a few words on who you are and what you do?
Yeah, thanks, Jochen. Hi, everyone. I'm Shruti. I'm also a writer in AI Infused and professionally, like how Ben has kind of like described, I'm also into one of the AI roles. I've been working as an AI engineer for the past 3 years, and I recently moved into a more agentic AI focused role, helping people to kind of bring in sort of the right tools for the right tasks and yeah, to make their life easier and not busier.
Yes.
Thank you, Shudri. So, with that being said, we're going to jump right into it. We're nice and warm from this previous conversation we were having before we hit the go live button. And the first topic that we're going to address is generative AI is adaptable, but limited by its lack of forensic accountability. So, I'm just going to toss that out there, and whoever wants to grab that first, feel free to do so.
Well, I mean, I think this is by now a familiar problem, or at least some manifestations of it are very familiar. We've heard a lot in the media about hallucination. I tend to prefer the term confabulation to describe what's going on there. And we've also heard something about the so-called interpretability problem. I think a very fundamental difficulty with large language models per se is that their outputs are. I mean, the analogy might all, and I emphasize, I don't mean this in a pejorative way. The output is almost like it's analogous to a Ouija board with billions of hands on the planchette. Indeed, I mean, if you think about the way a seance goes, I mean, it almost is like humans implementing a next token next token prediction algorithm. We're drawing on a kind of holistic statistical assessment of a huge body of documentation. I mean, for all intents and purposes, everything that's on the internet, to generate outputs that are, in some sense, fundamentally conjectural. They are conjectures about, in the sense that they're the likeliest output given the semantic mean of the internet, so to speak. And that actually that enables a lot. I mean, the capabilities of these things, particularly stylistically, and in terms of the kind of input that they'll accept, is phenomenal. But the algorithm does not guarantee that the output is going to be truthful and accurate. It's at best as accurate as the training data, and if there are hidden confounds in there, statistically speaking, that's going to be reflected. And I think you've also, I mean, there are further questions about that can be posed about creativity in connection with these systems. If you think of creative or innovative results, they're actually low probability relative to everything that's known. You might say they have a high Shannon entropy. If folks are familiar with information theory, but they also have very high utility for the user. And I mean, if you think about those as constraints, that's actually very, very hard to achieve, even for human beings. For large language models, you have the difficulty. The only way of, so to speak, dialing down the probability of the output is by dialing down the sampling temperature or the neural nets that are involved. And that's in addition to producing maybe a handful of very useful results, it's going to produce a ton of gibberish that those are embedded in. And then on top of this, we have the interpretability problem. And the best way I can characterize that is, I mean, even when these things appear to be doing reasoning, that's really more like a prediction of what, again, to anthropomorphize what the system thinks the reasoning should look like, based on everything it's been trained on. And the actual internals of the processing are very, very hard to recover, because they are, so to speak, holistically stored within this, this very large matrix of connection weights. And, it is so, this is not easily rendered in anything, in any format that a human can understand. And a lot of some research has gone into this, and it's the suggestion is it's not really reasoning the way we think of it, and so this is this is a further issue with the implementation.
Jyoti, what say you?
Yeah, thank you, Ben. Thank you for bringing up the concept of like explainability and interpretability, and also like I really liked when you said like it shouldn't be called as hallucinations and more like confabulation, because there is also many people assume that the LLMs are making things up, but in general it's not like really like making things up, but it's kind of like feeding you the information that it thinks could be the next probable token that you could imagine. Yeah. So this is something that I also find really fascinating and in need, because when it comes to like productionalizing things, when it comes to like developer productivity and so on and so forth, what I see from the circles that I work with and the services that we use on a day-to-day basis. So 2-3 years ago, I don't think coding agents were like very prominent. Like in general, they were not kind of like giving you the exact results that you want. It was not integrated inside your IDE of choice or anything like that. But the moment you integrate them, they kind of like walk through your whole code. But one thing that they miss, I think we'll address this also in the second part of the topic that we want to go through, which is basically the interoperability, the dependencies between how each and every code is related, else it just things. So let's say we have like a module which is probabilistically related to another module by name, by semantics or something like that, but it belongs to a completely different dependency that's not even part of the existing code base. So we are like facing problems such as how we need to search hybridly, how we need to kind of like bring this sort of like links and connections before we actually feed it to the model, so that the model know probabilistically where it could go further and further and further. one thing that also really surprises me is that like the model providers are like super fast in shipping new features, like especially with the large language models. I think it's been like shipped out every now and then. And then like when we go back to asking like what changed within like the versions or what changed, it's mostly like functional, like on a high level. It's not coming from the research level. Like nobody's saying that we're going to change the architecture of a prominent large language model, but rather they go into the direction of like we're introducing a feature that kind of like lets you, let's say, compacts your tokens, or you can use it to onboard and so on and so forth. So I think having the sort of like interoperability and interpretability is in general very useful, and it's also like very much in the need. Now we don't like see it because it's all in the research state, but I could very well assume sort of that it's going to change the futuristic way of how these LLM based toolings and distributions are going to like play around. So yeah, that's my opinion on it. Jochen, would you like to add something to it?
Yeah, that forensic accountability aspect is what I'm fixated on, because that's what says pass or fail. This is what is useful in the real world applications that have real weight or will have an impact in our world, in its utility. If you can't trace what decisions are being made, and how those functions are being tuned, or how you can predict the performance of a system, and you can audit it, and you can have regimented tests to go against to make sure that it's compliant and conformant with the performance you need for diagnosing someone with cancer, or helping a lawyer find particular bylaws, whatever kind of case is representative of what they're trying to solve in the courtroom, or whatever. Like a financial analyst can provide you with, here's my recommendations for how you should be betting or hedging or putting your money, and how much risk is involved based on these factors. Like, if we can't trace things back and understand this in a white box scenario, even if we have like a log, it's just a superficial representation of what's actually happening, but not actually giving you a magnifying glass and showing you A, B, C, D. Here are the actions that happen in a sequence, and how you can trace it back to make sure you understand where everything's coming from. So that's the angle that everybody seems to want to resolve with brute force, but it's in its current state impossible from where what we're discussing. But let's take a look at bullet number 2, because we have the opposite side of this coin, right? We have symbolic AI. You know what, Ben? Please, you tackle this one, because I'm going to butcher that word, compositionality, or whatever.
No, you got it yeah, you got it exactly right. So and you no and you I think you are quite right in saying this is the other side of the coin. Symbolic AI, I mean, the research on this goes all the way back to the mid 1950s. I mean, formally, it really starts with the so-called Dartmouth Conference in 1954, where you had a lot of the then Young Turks, and they became luminaries of the field, people like John McCarthy. And I mean, the idea here is basically to try to model human knowledge using symbolic logic with a set theoretic interpretation. In contrast with LLMs, this is not natural language at all. It's highly formalized. It has at least, as long as you are sticking to what is called first order logic. In other words, you're not making statements about other statements, or statements about that treat classes as first order objects and predicates. You can have very stable semantics, because the individual, you have interpretations for all of the individual terms in the domain. And you have you know what the extensions of the classes and the predicates are. Everything else is defined in terms of Boolean logic and universal and existential quantification, and that's where the compositionality comes in. You know, given any statement in the language, you can determine a truth value for it based on these very basic assignations of that map between the denoting terms and your model. So, and by the same token, all of the inferential results in the system are like mathematical proofs. They can be automatically checked, and it's it really is in some sense the result is absolute. I mean, you can't. It's it really the log, so to speak, here that is the justification. It really is a forensic audit trail of how the reasoning was done. So if anything goes wrong, it can always be traced back to some axiom or statement within your reasoning system. So debugging is very straightforward. Now, the downside of it is that, I mean, you heard me mention second order logic. There are a lot of things in the real world that involve context. So, for example, you and I and Sru3 are currently participants in a conversation that's happening right now. We were not participants in this conversation an hour ago, and we won't be 2 hours from now. So there's a temporal bounding, a temporal context for that. Similarly, I mean, another thing, we've talked about this in connection with large language models. If you're going to understand things like use contexts and users, you have to model the way the user thinks about the world. And so that's a relationship between a user and a particular set of axioms, which is a second order relation. And the more of this that you have to bring in to your representation, the higher the overhead, the costlier it gets, and the trickier it gets because of issues with the semantics that trace back to things like the work of Kurt Gödel, who basically showed that with certain axiom systems, I mean, the best way I can think to put it in this context is, if they are complex enough to be interesting, you're going to have results that are true but not derivable. And that implies in turn an incomplete semantics for the system. So you have, there is that issue. There's also, I mean, another thing, and this intersects in a complicated way. Sru3 talked about interoperability, and there is a lot of interest right now in so-called using semantic layers to map between, to support or afford inferences or questions that integrate across different data silos that use different representations. The idea is you map all of the schemas into a common ontology, and the data and express the data in that lingua franca, and then you can do reasoning about all of it. The difficulty is that you can never anticipate all of the issues, the representational issues that a new data silo may bring to bear. You can't have an ontology that is, so to speak, one size fits all, or that's never going to require revision in light of new knowledge. And you can have n+1 data silos successfully mapped into your ontology. In data silos mapped into your ontology, and the n+1th is going to require significant, they require you to do significant re-engineering. And up till now, the human overhead and cost of all of this ontology maintenance has been a challenge, and it would be useless to deny that.
Thank you, Benjamin. Shitri?
So yeah, I think like it's kind of like very well said on what Ben kind of like mentioned about this whole symbolic AI space and how it's like evolved and how it's kind of like vital. So I also see this in a very same way, but probably like from what we do, right, like in the application side of things, at least like during my studies or like the current kind of consultings or some kind of like things that we do, we kind of like see this done at the end rather than in the start of something that we do, right? Like is this something, for example, you mentioned like ontologies and the handling the data silos and so on and so forth. And one of the major problems that exists in today's world is basically the heterogeneous sources of information that they kind of like come in. And as I think Ben also addressed the need for semantic layer in whatever thing that we want to power. So this kind of like initially like we somehow get the data in and there is no semantics or something that we are trying to like pull it with each other, because the topic, like I don't want to kind of like drift, but I think there is like many factors other than the human factors. There is also like a layer of like compliance, security and whatsoever. And then at the end, when we want to change something, I think that's what is happening in today's world, that the heterogeneous sources somehow have an ontology which is not fixed, but once it's kind of like stable, I don't think it's going into like the changes that we want to do, because it works, and why to kind of like change it. What do you in general think about it? This, for example, one example scenario that I could think about is, let's say like conventional coding, like nobody touches like a COBOL system because yeah, you know how it is hard to know the data sources. Is this calling the right data source? Is this the right way to kind of like disrupt the ontology or something like that? Do you think that people are doing it at the very end so that they have a fixed schemas whatsoever? Or they already like did it in the past and they are not like changing it because they feel that something can break? What do you think this like perspective?
Yeah, no, I think my sense is that in the industry, a lot of it is done at the very end. I mean, for one, and partly for reasons that you alluded to. I mean, it's not just like, old COBOL systems. I mean, legacy data in general is, it presents a real challenge, because with many, and it's not clear that data standards alone are really the only. I mean, they may well be part of the solution, but the problem is you always have legacy data that either didn't conform to the standard, or for whatever other reason, you have these idiosyncratic database schemas. And it gets worse than that with many of these databases, in that very often the column headings do not wear their meanings on their sleeve. In fact, in some ultimate sense, they can't. And users coming to this data will often apply their own interpretations, and so even within the same database, you get these polysemous you get polysemous content where one user has interpreted it the column one way and another is interpreted a different way, and you've got both of those interpretations reflected in what's in there. And so in some sense it really becomes kind of almost a challenge in forensic historiography to go in there and try to figure out, well, how did the interpretation change? And if it's this type of thing, it means one thing. The interpretation is one thing, and if it's something else, it's another. And then you can to a certain degree, at least, you can with with formalisms try and address that. But it's very it's always, I think it's always going to be almost by necessity an ex post facto operation. Now, yeah, I mean it is a really, how to think about this. I mean it is part of this may in fact get us into the whole question of synergies, because part of the question ultimately is, can you have an ontology that, so to speak, adapts itself in real time as new data, as new schemas and new ways of conceptualizing things come into play. And Lord, that's the holy grail. Right now it can't be done without humans in the loop. And modulo a lot of what I can frankly consider to be overhyped claims in some quarters. Large language models aren't up to it right now, generally speaking. You can't get a large, I am very dubious about using large language models to build ontologies for given data domains from scratch. I think, there are a couple of things that it seems to me the technology is up to doing, some of which I have, real data points for. One is, while you can't build a detailed ontology that can support technical reasoning with an LLM, you can sort of you can generate a kind of sketch, a knowledge tree where maybe it's no more specific than like is narrower than and is broader than, and then you can go out to human ontologists with that as a starting point. Another great thing you can do is also we haven't mentioned subject matter experts yet, and they're a critical part of this process. You can bring them in and show them the rough graph, as it were, the rough draft, and they can comment on it, and then the ontologists can work to build a more systematic system. So you can sort of you can go from top down, as it were, very general, to actually building some more specific representations. Another thing you can do is take a pre-existing upper ontology with some mid-level and low-level representations in it. So you have, as it were, what's at the leaf nodes. And some of those, if you think they are in effect sibling representations to some of the things you're trying to deal with in your data, you can have the metadata on those in ways that maybe you can train a large language model to actually use, to where you can engage in a dialogue with the LLM for building out other parts of the ontology. And research has been done on that, and it does seem like it's.
I just want to stick in some primitives, because I'm a primitive kind of guy and I like to go to the fundamentals. I'm looking at this, like we started the conversation before going live, as a comparison between the rabbit or the hare and the turtle. You have this generative AI acting as a very fast, flexible, sycophantic, smooth talking apparatus, and then you have the deterministic turtle, that you have to uh, find the precise meaning of words and how you want to represent it and how you want to relate that to something and how you want to show the hierarchy of meaning in relation to terminology. And you have to do that for each word, one by one by one, and fit it in together like a jigsaw puzzle. But I also look at this like sand and stone. To work with sand, you just pour it in a container, and it takes the shape of the container. But when you work with it, it slips through your fingers, and there's no way to have a deterministic shape to it. It just kind of blends and moves to whatever kind of application you're working with. But when you work with stone, you have to chip with your mental, faculty to give it shape and form structures. And then as you said, when you have to integrate different structures, you're building bridges between structures. You're building um, auxiliary structures, like in addition to the house or a second floor. You have architectural considerations and how that meaning is going to be mapped over, and how you can reason. Well, I forgot to put a window. I forgot to put a door. Now I have to do some more work. But that's kind of the negotiation between those two things.
That's nice.
Yeah.
Maybe we could put
That's a
some.
nice analogy.
Yes, it is.
I'm a primitive guy, so I like to keep it simple. But
It's a very nice to, yeah. I think it's very nice to what Ben just kind of like helped me understand how you can kind of like, introduce these concepts inside the application side of things so we don't get like drifted away with all the noise. And I think you kind of like put a cherry on top with that example that we still like keep building it until we somehow are livable in that place. So yeah, I really liked how it kind of like came in a circle.
Yeah. The only thing I think it's a great analogy, but the thing I'll add is some decades ago, a gentleman named Daniel Kahneman came up with this model of human cognition where there were effectively two modes. I mean, I can never remember the designators he used for this, but it was essentially fast thinking and slow thinking. Where fast thinking, as he described it, is a lot more like what an LLM does. It's just a kind of very probabilistic, quick and dirty sketch that is produced in response to a dynamic operational environment. Slow thinking is analytic. It's logical. It requires more time and overhead, but it's semantically rigorous in ways that fast thinking is not. And in Kahneman's picture, these two form a virtuous circle with in human operations, or at least ideally they should. Part of his work was in studying how this breaks down, and it may very well turn out to be very quite relevant for the whole question of synergies between generative and logical AI.
Nice.
Well, with that, we're gonna leave it on a cliffhanger and keep you wanting more, because that's part of the fun. We'll come back in about 2 weeks with the next one, and we'll be percolating with some new ideas in the meantime. So
Yeah.
thank you for joining in.
Sounds good.
Thank you,
Thank you
man.
for
Thank you.
joining in. Have a nice weekend, everyone. Bye bye.
Bye.